Good morning, good afternoon, good evening. Welcome everyone to this presentation on how to accelerate your large-scale development with Eclipse. My name is Jed Anderson. I am the project manager for the SDC product line at Genuitec. And with me, I have Marcus Duff from SSI Shaefer, who is the, correct me if I'm wrong, the WAMAS architect. Is that correct, Marcus?
Yeah, one of the architects here.
One of the architects. We would like to start in right away, but if you have any questions on how to use the GoToWebinar, I wanted to address those before we get started. If you have any questions during the presentation, there is a questions panel in your GoToWebinar control box, and you can ask questions there at any time. We have people in the background who can answer them during the talk, and then we will address questions at the end of the talk as well. If you're having trouble with the audio, there are audio settings in the control panel, and if your video gets a little stuttery, we recommend shutting down any large downloads, things like that, that might be taking up your bandwidth. So with that, I'm going to hand it over to Marcus to get us started.
Hey, and welcome also from my side. My name is Marcus Duft, and I'm a software architect at SSI Shaefer. I'm really excited to have the possibility to co-present with Genuitec today, and we're going to show you how to leverage a whole bunch of Eclipse technologies like Xtext, RAP, and we're also going to tell you about Genuitec's SDC, of course, and how it helps us to get our job done despite the very complex problem space. But before getting into depth, let's start, have a short look at SSI Shaefer and our software product called VAMAS. The SSI Shaefer Group is a privately held company. It's rather large, as you can see here. I'm working for one of the members of this group. It's called Salomon Automation. That's a company inside the group. And we're contributing software to the group. So what kind of problems do we tackle with our software, or what problems did we have and what questions did we ask ourselves when planning our software product? The first one was how can we support our customers' logistics needs via networks of devices which span different technologies and locations. So we have very high demands to availability and performance. We need to support a broad range of low performance to high performance devices. We need to control a large number of different hardware devices like stacker cranes, conveyor belts, etc. So also a broad range there. Another question was how can we efficiently roll out changes to these networks? So how can developers efficiently make changes to the software and roll them out so that they're live in the productive system? How can each developer keep an overview of the system and keep track of the running software? So we have questions from the very beginning, from developing to deployment, that we needed to answer. So we answered actually most of them, and today we're going to show you a little bit of how we did that. So now let's have a short look at VAMAS itself. What is that? VAMAS is an acronym for Warehouse Management System. It's essentially keeping track and managing goods as they enter, stay in, and leave a warehouse. So it controls all the movement inside of the warehouse, including the locations where goods are stored while waiting for them to be requested. So VAMAS also needs to keep everything safe. So it has some security constraints. For example, it will not allow you to place pallets on rack fields that cannot handle the load. So if they're too heavy, it will prevent that. Also, VAMAS takes care of all the routing in the warehouse. So it sends the forklifts back and forth between the locations, tells the people where to go, where to pick up goods, and where to bring them. And of course, the ultimate goal of VAMAS is to make sure that the right thing is at the right place at the right time. So for example, you don't want the truck driver to wait at the gate for his pallets to arrive, that he needs to load into his trailer. Here is a small technical diagram of the system. I'm not going to explain every little bit of that. It's just to point out that we're interfacing with a superordinated ERP system, which gives us orders, which WAMAS then executes using its processes that are programmed in there. And to do so, it interfaces with a lot of hardware and devices that execute the actual actions. So how did we get to where we are now? So we started out with Eclipse as a development environment. We chose that primarily, as I heard a few days ago, because of the compiler performance. Back then, it was way better than the Java C compiler performance. As a logical consequence, later on, we continued on that road and embraced Eclipse and built on their technologies so that we can focus on our core competency and don't need to implement loads of framework stuff and so. Thus, we wrote RCP applications and developed them inside the Eclipse IDE. And then afterwards, to keep inside the Eclipse family, we now even deploy our RCP applications using Eclipse technology, namely Secure Delivery Center, Genuitec's SDC. And so we're practically completely inside the Eclipse family. So now that you know a little bit about SSI Shaefer and VAMAS, let's have a look at how we tackled our problems by giving you some examples. So the first topic we faced was the IDE. So we need some tooling to be able to develop our software. And we actually need a very reliable and reproducible setup for developers so that they don't have to spend hours for setting up. To accomplish this, the setup needs to be in a single package that's easy to install. So we have a neat little install wizard, which gives you next, finish experience. And it includes everything. So it includes Eclipse and all the required external and internal software. It provides a mechanism for initial workspace configuration. So it will guide you through the process of retrieving the sources, setting up the workspace and stuff. It also includes the required target platform bundles, so you don't have to download anything except for the initial setup. And yeah, it just has to set up the right thing. So it must make sure to clone the correct repository, because cloning the wrong 2 GB repository is a huge waste of bandwidth. And while thinking about that and defining our package content, we actually discovered that the hard problem isn't building the initial IDE package, it's keeping it up to date afterwards. So when developers install from a zip file, they actually have no good way of keeping their installation in sync. And that's actually where we started looking out for a solution to that problem. And at Eclipsecon, we stumbled upon SDC and Genuitec. So that's how they came into the play. So Chad, can you tell us a little bit?
Yeah, sure. I'll step in here. So maybe before we go into what is SDC, let's talk a little bit about who is Genuitec. We are the cloud control company based in Texas. We are Eclipse experts. We've been a part of the Eclipse community since the foundation was started in 2001. We actually have people on staff who were part of the Eclipse committer community even before it was open source. So we have a lot of history inside of Eclipse, and we have a lot of products based on Eclipse, the My Eclipse product line and all of its variants, and then Pulse and its new the new generation of our delivery platform, SDC. With all of that Eclipse experience, our customer reach is really wide, and so you may be asking yourself, why would a very large company like SSI Shaefer decide to team up with a little player like Genuitec? And I think the answer is that we do have such a reach throughout the Eclipse community, and also SDC answered the questions that SSI Shaefer was asking. Um, so to talk a little bit about what SDC gave SSI Shaefer, it is about providing that next finish installer that Marcus just talked about. And in fact, we have a little video of that happening. Let's just take a little time to watch that while we talk about the different aspects, right? You need to install the software, obviously, your base Eclipse. Then you also need to install extra plugins, for example, find bugs or check style, some code quality plugins, or maybe you have generator plugins or things like that. So you have to have those installed. Then you have to configure all the plugins in your workspace. So do the settings for Eclipse preferences. You have maybe settings for these extra plugins. Maybe you have to drop in a license file for a piece of commercial software that you need in order for your developers to use that software. Once you have all the settings of the workspace in place, you also then want to think about providing each team that you have with its own set of projects. Like Marcus said, you don't want to clone the wrong repository and have the developer then have to go back and add new projects or add different projects in. So you want all of that to be automated from the get-go so that you can on-ramp your developers quickly, but then you also want to keep everyone up to date. And so that is the solution that SDC provides for SSI Shaefer and other customers as well when they have lots of changes that they need to make to their workspace, or maybe not even lots, just a few changes over time multiplied by a couple hundred developers, and you start to see real numbers add up in terms of developer time. So as you can see here, the workspace has been provisioned. It was empty. It has been filled now with the plugins. The developer is ready to go at this point. But not only did SSI Shaefer have a problem of getting Eclipse and keeping Eclipse up to date on their developer's desktop, they also have a problem. Actually, they had an architecture designed already for deploying their applications to their devices. If you remember back to that slide with the field of blue boxes everywhere, and there are little white boxes along the conveyor belts. Each of those is running an Eclipse application now. And SSI Shaefer needed to push updates to those Eclipse applications in those devices and do it in a way that was organized and controlled. So they had designed an architecture with a centralized server that would do the management of all that, and they had started that implementation, and they found out that it's a hard problem to solve. And about that time is when, as Marcus said, they stumbled into us at Eclipsecon, and they were saying at the time, we're just looking for an installer. And we said, we can do installers. That's something we're good at. And then we started talking about their architecture, and we realized that the two architectures overlapped to such a degree that they could actually use SDC as their centralized server inside their warehouse. So this is a lesson of how you can go to the Eclipse community looking for a problem or a solution to your problem, and then find out that, okay, there's a larger problem here that the Eclipse community also solves. With SDC, now WAMAS can be distributed via one file all over the world. So they've got installations in many places. Each installation is slightly customized for the customer at that site, and they can efficiently push out a WAMAS, we call them packs. You can push out a WAMAS pack to that site and have it deployed in one action. And so that allows SSI Shaefer to be able to effectively roll out changes. You know, the user finds a bug, the bug gets fixed, they push out the change all in one action rather than having to, you know, shut things down and start things up and things like that. So I talked about going to the community, looking for solutions. There is gold in open source. We know this. You have to know your problem before you go looking, but once you know your problem well, you actually can reap the benefits of the open source quite dramatically. And so Marcus, why don't you tell us about your database tooling and efficiencies and how you were able to find gold in the Eclipse community?
Sure, thanks. Yeah, we had a rather inefficient database tooling, as Jed already mentioned. So what we originally used was a UML modeling. So we have drawn our database model in a commercial UML tool. And that was actually a teachers and error-prone approach, actually, because it turned out that we have a lot of metadata that we mix into the UML models, which are then modeled as tagged values or stereotypes, which is just essentially plain strings, so with no checking and validation on them. And the UML models were stored as binary, which is was a huge problem because they're not mergeable. So with a lot of development branches, the developers had to redo every model change on every branch that it was required for. So we stepped back a little and had a look at what we had and asked ourselves the question, why do we do it that way actually? And we found out that we have generators that generate Java source code from the UML model and as documentation purpose. So we want to have a picture that shows our database model so that consultants, developers, and externals can have a look at the model and understand how it looks like. So what did we do to actually solve these problems? We turned to Xtext, which came to the rescue, and switched to that. So we invented a DSL that is with a precise syntax that is exactly suited for our needs. So all the metadata that was actually previously modeled as tag values or stereotypes is now built into the language. So there are keywords for all the different things that we want to model inside our database model. And that makes it way more easy and less error prone to model our database. Also, validation is a lot better now because you can get validation already inline in the text in the IDE in the editor even before running the generators. Also, the generators, of course, have been switched to the new modeling technology, and they have also a way better way now to validate the models. The generators, they're actually still the same as they were before. So what we did was only swap the backend, so to say. So previously it read in UML models and merged them and patched them and tested them and validated them. And now it does actually the very same thing with the DSL models, but it's way easier now. So the backend got way more lightweight. The documentation is also still there, so we still have pictures. These pictures are now generated also from the model, and there is actually two ways to get to those pictures. So we created a view in the IDE, which is able to render diagrams on the fly automatically using GEF and test from the selected element in the Xtext editor. And there is a way to manually specify diagrams with a mechanism that's built into the language. So there is a little layout language, so to say, inside our DSL, and you can define diagrams with relative positioning. So something like this box is right of this box is below this box, and so on. So it's pretty simple to come up with meaningful diagrams. The feedback from our developers was very positive. So they told us that they can work way more efficient with this tooling, and everybody is actually satisfied with the pictures also. So the quality of the diagrams actually didn't decrease. Another technology we're leveraging from the Eclipse open source community is RAP. So why is that? The original request for a web application came from our customers. So they wanted to have that for two purposes. The first one is that service technicians that maintain a lot of installations of WAMAS, they don't actually want to install a WAMAS client for each and every of these installations, but rather have a URL they're navigating to and have the application live without installing. That was the first one. And the second one was that one could easily give a small part of the application as a web interface to externals so that they can also work with WAMAS from an external point of view. So we had a look at our existing application, and actually we wanted to have exactly what we already have, only as a web application. And we found RAP, which actually is a drop-in replacement for SWT, so that fits in perfectly. So currently we're in a situation where desktop and RAP applications share approximately 95% of their code. So only the framework differs a very little bit. And for example, we have a different implementation of the table widget for the two applications. On the desktop, we can use Nebula's NUT table widget, which is pretty rich and allows us to do a lot of sophisticated things. And on RAP, we use the less powerful SWT table widget, which is enriched a little bit by RAP themselves. So we also have a few features there, which are pretty cool, but not as much as in the desktop application. And also in very, very little places, we have to resort to using reflection because we have code that's executed in both applications. For example, some UI framework code where paint listeners are registered or something, things that are not available in RAP. We use some helpers that resort to using reflection to execute this in the SWT application and not execute it at all in the RAP application. Now, what if you can't find it in open source and you can't buy it? That pretty much looks like you'll have to do it yourself. So one of the largest problems we actually couldn't solve using open source technology, or we did solve it, but with some getting our hands dirty, was the insufficient build performance. So when our software was growing to approximately, it was like 600 bundles in the workspace, we encountered some performance problems with the build. So it took us like somewhere in the area of 40 to 50 minutes to build a workspace from scratch to a working software. And that was, of course, not acceptable. These numbers are actually not pure compile time. They're involving like some automatic build, then running some generators, then again some build steps, then again generators, and so on. So there was a lot of manual stuff in there. Also, we were observing the build, we were profiling that and found out that the actual compiling was fast enough. So that was not our problem. The problem was that PDE was trying to find out the build order of plugins, and that was really slow because it tried to resolve dependencies using package import. And package import works like, I want to have this package and I don't care who gives it to me. So the environment needs to find out which bundle is required to resolve this dependency. And that was that slow. So we then resorted to using require bundle instead of package import exclusively. So we're only using require bundle now and rewriting the dependency resolution so that we can calculate the beta order, but more on that later. The generators, of course, are also an issue because manual steps in the build will always slow it down. So we needed a way to automate this. And our generators cannot be put into the Eclipse builder infrastructure. That's because they're actually operating on data that is only available inside of the WAMAS target platform. So we cannot simply run that code in the IDE itself. Also, the numbers on the slide here, the 40 to 50 minutes, are a little bit old already since we have a working solution for years now. So don't get scared, they might be better by now. So what we came up with to tackle this problem was the so-called WAMAS power build. It is a small customization to the IDE, and it's actually not much magic. All it does is this aforementioned calculation of the build order. And then it calls plugin.build, just the straight API that Eclipse provides to build a bundle. And it does this by ignoring package imports. So we're using require bundle, as I said, and that makes it actually blazingly fast because it's not much information that is to be considered. Also, this calculation of the dependency graph gives us the possibility to integrate our custom generators. We can easily insert nodes with special meaning that will trigger running a certain generator before building a certain project. So that's easy to do in that way. All in all, this helped us to reduce the build times down to 4 to 9 minutes, somewhere in that area. And that even though we have roughly 40% more bundles in the workspace right now. So that's pretty awesome. Another crucial, actually very crucial point in that WAMAS Power Build is that we have a reproducible build environment based on top of that. So previously we were working just like mostly everybody else, I think, by using the automatic build in the IDE and Maven, Gradle, and whatever, some external build system in the nightly builds. So that caused us a lot of headaches and problems because the developers themselves were actually not able to reproduce problems in the nightly build because they just simply could not run all the infrastructure on their development machines. That's now possible with WAMAS Power Build. Actually, the IDE and the nightly build execute the very same code. So there is a menu item to run the build, and this will do exactly the same thing as the nightly build if it starts headless. And this is necessary, for example, if there are customizations on site while commissioning a warehouse. The developer needs to be able to fully build and push out a WAMAS version from his developer machine. So he should not be bound to a nightly build machine and bound to wait for that just to roll out his changes. So, Chad, let me hand over back to you.
All right.
About deployment and testing.
So not every installation of WAMAS is out of the box. There is a WAMAS Go product, but most of the time when SSI Shaefer goes to a customer to commission a warehouse, they have to do customizations. And so you want the developers who have to go on site to be able to do builds, like Marcus just said, but they also need to be able to do deployments in an identical fashion to how deployments would be done otherwise. And so the reason for that is because you don't want to introduce any errors into these systems, right? You're looking at a lot of machinery and a lot of downtime that could be prevented. And if you have downtime, that means a lot of lost money for these companies, right? So you need a way for developers to be able to not only build, but also deploy WAMAS in a way that is as identical as you can to the way things normally happen. And so because of that, SSI Shaefer has integrated pushing a WAMAS pack to a deployment from within their development environment. And so this means now the developer can run the WAMAS power build, get an exact replica of what the nightly build would produce, and then also deploy it to a WAMAS installation somewhere, and do that in the exact way that it would get deployed via a nightly. And so this reduces the error possibility in the system. And when the new pack is deployed to the system, then SDC takes over and does all of the necessary reprovisioning of the RCP applications to the different devices in the system. So this is a way for SSI Shaefer to not only test changes that they've made to particular WAMAS installations, but also to deploy to end customers as well, and is very effective at reducing the errors in the system. Not only that, but they also integrated SDC remote control, which is, you see this little console. It is a remote console for deploying WAMAS packs. This was actually requested by one of their customers so that they could do reprovisioning at a certain time at night using a cron job. And so that sort of control allows their customers to tightly scope when they want their WAMAS installations to upgrade. I think they're down to wanting 15 minutes of downtime a day. That sort of limited downtime. So that's another example of how you can get your hands dirty a little bit with Eclipse and actually come out with much better results, right? We're talking much improved consistency across all of the build and deploy parts of SSI Shaefer's software problem. So we've given you some examples of how you can buy or find solutions in the Eclipse community, how you can build your own solution on top of Eclipse with a little bit of elbow grease. We'd like to ask you at this point, what can you do with your large scale deployment with Eclipse? What problems are you running into that you haven't solved yet because you haven't identified them or gone looking for them? And if you have any questions for us on how either Genuitec or SSI Shaefer have solved their Eclipse-based issues, we'd be happy to take those questions now. And we'll wait for a few questions to come in. Here's a simple one for WAMAS. What kind of different devices do you control with WAMAS?
A lot. So the range is actually so mainly we're controlling devices that aid manual warehouses. So we have handheld devices that either have a touch screen and a keyboard and a scanner and wireless, and also voice devices, which only work with voice recognition, and normal PCs, of course, up to controlling then large scale automated installation with conveyor belts and storage retrieval machines and stuff like that. So from very small scale to very large scale, from very underpowered actually. So these handheld devices, they don't have very strong CPUs. They're running Windows CE and Java 3 applications and stuff like that. So yeah, that's basically it.
And a related one, are these RCPs headless, or it sounds like some of them are not, but are there headless RCPs in the system as well?
Yes, of course. So what we're doing is WAMAS consists of a server part and a client part. So actually multiple server RCPs and multiple client RCPs. The server RCPs are installed on the SDC server and are controlled and actually managed by the SDC server. And they in turn control then the smaller scale mobile devices. So we have a very lightweight client on those mobile devices that's written in Java 3 and is controlled by the server RCPs directly. For the desktop clients, so for normal PCs, this is not headless. This is a normal RCP application running atop the Eclipse Workbench technology. So it's a standard desktop application.
One for SDC. What installer technology does SDC use? It doesn't look like Install Shield. That's correct. It's not Install Shield. It's actually an installer technology that Genuitec wrote called OneInstall. That is fully integrated into SDC now, so you don't do anything to create installers other than create what we call packages and then have the system build those packages. And then installers come out the back end, and you can ship those around to your customers either as files that they run, or files that your software management system runs to deploy the software onto desktops, and then your developers can get updates to those packages over the air using P2's normal, well, an optimized version of P2's update mechanism. Is WAMAS Power Build generally available to the public?
Actually, no, but but it's not so complicated actually. The real meat of the Power Build that handles all the dependency calculation and building the bundles is actually not much more than like 1,000 lines of code. So as soon as you have the correct idea, I think it will be pretty easy for nearly everyone to get his hands dirty.
And here's another interesting one about migration to Xtext. How did you migrate to Xtext?
Well, we did that by just replacing the backend. So we took great care that actually the generators and also the generated code and the runtime model used inside the application stay the same. So up from the generator upwards, everything stayed the same. We just replaced, we just replaced the UML models, the editor, and the reading of the model by the generator. So the generator uses now a different reader to read the models, and that's it, basically.
Okay. How does SDC keep workspaces up to date when changes occur? So SDC uses a mechanism, they're called workspace tasks, to do modifications to the workspace. And when you build a new version of your package, those workspace tasks are pushed out to the client. And then at install time, or sorry, at workspace startup time, or when the updates are applied, it will see, oh, these tasks need to be run, and the tasks evaluate whether or not the system is in the right state. And then if the system is not in the right state, then the tasks do actions. So for example, it might load a target platform, or it might import projects via an Eclipse project set file, or it might change preferences based off of preference file. And SDC supports a handful, I think like 6 standard file formats for that, and then you can also write your own if you've got your own little workspace task that needs to be implemented.
We actually did that. Sorry to interrupt you.
No, go ahead.
We did that for the checkout. So we have a custom workspace task that opens our checkout wizard, which is tightly integrated with eGit and JGit. And then afterwards imports all the projects in the correct order and puts it into the correct working sets. You saw that in the video previously, actually.
Yeah.
That's one of the custom ones.
It's a great example. We have other examples of customers who have used those tasks to add buttons and then tell users that their buttons are there, and it's very flexible. It's really a great part of SDC. I guess on that, what kind of version control do you use in your workspace? It sounds like it was Git.
Yeah, we're using eGit for version control. So we have a Gerrit server, a central Gerrit server. We're using the review process from Gerrit, so mandatory. And on the client side, we're using eGit and also integrated quite tightly into that. So for example, this clone wizard and project organization wizard, this uses a lot of the public APIs from eGit and JGit to make it very easy for developers to set up their initial workspace. So it will pre-fill out URLs, it will handle all the setting up the Gerrit stuff and configuration. It will import the projects based on a configuration file that defines which kind of projects to import and where to put them, and create working sets and stuff like that.
It sounds like the topic of another talk, actually. Let's see, another question here. Do you have any numbers on cost savings of using Eclipse during development? I think we could probably both speak to this. I know Genuitec has done a case study on this and found um, that a developer would spend about 2 man weeks a year just doing tooling setup and workspace management, I guess. So multiply 2 man weeks times the number of developers in your team times the average salary, and you're starting to look at real numbers, real money. Um, and we found that if you have a team anything more than about 3 developers, the return on investment actually made sense with SDC. Then you have one developer do that setup over 2 weeks, and everyone else just takes the changes that they made, and then people don't have to think about keeping their tools up to date, about keeping their workspaces up to date, and their preferences, in line with company policy. I don't know, Marcus, did you have anything from your side on that?
Yeah, it's hard to compare because we always use Eclipse, but what I can say is that, for example, the switching from UML modeling to Xtext, these swapping in Eclipse technologies saved us a lot of time because now, as I mentioned before, the formats were not mergeable. You had to do the changes on every branch and stuff like that. So that's the things where we have a huge benefit of using Eclipse technologies or Xtext in that particular case, because it's just like it takes a fractional amount of time to do database changes now versus before.
Here is a question about Eclipsecon Europe. Actually, yes, we will be in Eclipsecon Europe next week, both Marcus and I. And in fact, Marcus has kindly agreed to show up at the booth if anyone has questions about their installation. Look for us at the Genuitec booth. I think we're up on the second floor this year. So we'll see you there next week. And I think that's about good. We're almost out of time here. So with that, I'd like to say thank you, everyone, for your kind attention. And Marcus, I don't know if you have any closing words yourself.
Yeah, thanks for listening. It was actually fun for me to do this. And I hope you got some information out of the talk.
All right. Thank you, everybody. Bye-bye.
Bye-bye.